Hey everybody. Today I'm going to go through Economics of Education's first assignment as an answer key. So we're going to go over the questions, the answers, and a little bit of the intuition that I expect you to get from these problems. We'll go through it medium speed, hopefully, because we've talked about this stuff in class. But what I'll take from you all is your guidance and what you found the most troubling or the most interesting, and what I saw might have been the biggest problems in the assignment. But if you have other questions, please feel free to let me know, and I'm happy to give you more feedback and give you more information. So let's get started. So this is assignment 1, looking at the first couple of chapters of material. And the first question I have you graph right away, and it asks about the market for education. And this is from the beginning of the chapter where we're really trying to get a handle on how education markets work and how they're different from other markets. And so the first question asks you to draw the market for education, talk about what's on each axis, what makes up the demand, and who makes up the supply. So let's start here. We're going to do our market for education. Give me one second. There we go. I want to make sure you can see everything. And we're going to have the quantity of education down here. And so that can be anything like years of education, number of schools, hours of education, some quantity of educational attainment. And we can also think about it being things like grades or schooling or levels of academic achievement, those kinds of things. And then over here, we're going to have costs and benefits, right? The value of those things. And since we're in the US, we're going to use dollars. But the idea is that there's some cost associated with producing education and some financial monetary benefit associated with getting an education. And then we want to get our demand curve. I like to start with demand, so I'm going to draw the demand curve first. And who makes up demand for education? Well, it's going to be students, right? Students demand education. But we said that it's not just students. Oh, that pen is dying. It can also be their families. And depending on what our model of education is, if we're talking about human capital model of education, it could be society demanding education too. But generally, it's going to be those people who want to be educated and the people who have a vested interest in them. So families and loved ones, that kind of thing. On the supply side, the supply of education is going to be given by educational institutions. But that's more than one thing too. Educational institutions can be private schools, public schools, for-profit, non-for-profit schools, and education is supplied through a lot of different dimensions, and so it's actually a pretty complex supply function and a pretty complex demand. And so that's kind of that first swipe at things for part A. For part B, we want to show what will happen to the supply and demand curves if more schools are built. And I realize this might be phrased in a little bit of a confusing way, but the idea is I want you to disentangle whether it's a supply effect or a demand effect, and then what the nature of the effect is. So first we're going to look at building more schools. So if we increase the number of schools, you want to ask yourself, is that going to affect demand or supply? Well, schools are not on the demand side, right? They're on the supply side. Schools supply education. So if we increase the number of schools, we're going to have the effect of shifting that supply curve out. Or I'll make that B for part B. And that's going to increase that equilibrium quantity of education to a higher level, right? QA, QB, and so on. Cool? Makes sense? Hopefully that's pretty straightforward. Some people tried to shift both supply and demand, and we don't expect that to have an effect on demand necessarily. It might move us along the demand curve, but it's not going to increase the demand for education at every price level, okay? Let me know if that makes sense. The second effect was to see part C. What will happen to supply and demand curves if the wage returns to schooling increase? And this is the same thing. Now we're talking about increased benefits associated with education, right? Increased benefits, increased returns to education. And you can think about that from your own experience, right? What happens if you find out that you can make even more money than you previously thought from getting an education? That's not going to affect supply. that's going to affect demand, shifting that demand curve out, increasing demand for education at every level, right? Make sense? Cool.
Yeah, I mean, and then they start like with the announcements, like 1 or 300, but it only really like 2 weeks.
For number 2, we want to talk about, this is more of a discussion question. It asks how a local school might have a monopoly on education. And this is a locational issue. And it's what we're really talking about is K through 12 education, but you can apply it to higher education too. The idea is that the way we allocate students to schools in the US, especially K through 12, is going to be as a function of their location, especially public schools. And so you might live somewhere where there's only one elementary school or you don't have a choice about what school to go to. And so that school has a functional monopoly over education for that region. And so it's this intersection of the way our education policy works and this sort of locational component that creates this monopoly where, there's only one high school in your neighborhood or there's only one whatever. But even if we take it to higher education, we can see the same general effect. A lot of students in Sacramento go to Sacramento State or an outlying regional school because we're more likely to go to school closer to where we are. It's lower costs in terms of information, travel, etc. So even if you're not from the Sacramento area, my guess is a lot of you are probably from California or nearby-ish. So that's the general idea we're saying is that people are more likely to attend schools in their neighborhoods, and so those neighborhoods then sort of form these sort of locational monopolies. Make sense? Number 3 asks how randomized control trials overcome selection bias and how a researcher might overcome a selection bias in a non-experimental method like regression analysis. And this comes from us talking about the empirical tools of economics and education economics. And so the idea here is that we have 2 sort of subsets, 2 options for conducting research. We have experimental methods and non-experimental methods. In experimental methods, a randomized control trial is the gold standard. It's the ideal because it really helps us control selection bias. And so you have a sample population that is sorted into control and treatment groups at random. And so the control group is not getting the treatment group is, and the assignment is random, and usually the participants don't know which side they've been assigned to if we can control for that. And so what that does is it prevents a lot of selection bias, and the experimental nature of the design helps to make sure that we're sort of controlling for other variables through simple things like just having a big sample. So that's the big idea. It allows us to view the counterfactual and the treatment. So basically see what would have happened if we didn't do the treatment and what happens if we do the treatment. It also kind of helps to control the placebo effect. And then also it can try to help control, if people don't know which group they've been assigned to, it can help control the Hawthorne effect. And remember, the Hawthorne effect is the idea that knowing you're in a trial can change your behavior. So that's the first half. The second half asks how you could control for your biases in a non-experimental setting with regression analysis. And there's a lot of different ways you could answer this question. You can talk about trying to select or produce an unbiased sample, have a really large sample size, have a really diverse sample. That's a really good way to help prevent selection bias. You want to think about like random samples being some of the best types of samples that can control for that. So those are some answers to how you might want to do that. Okay, so far so good. Hopefully that makes sense. Next we have a regression equation. And I wrote it down twice, and so I'm going to write it up here and we'll break down the answers to the questions and talk about it. And this is from that same chapter, and what we're looking at is how a regression equation functions and what we can use it to explain. And so we've got a regression equation where we have wages, and it's a panel data set because we have observation level and a time level, and it's going to be equal to some constant, 1.76 plus 1.2 x1 IT plus 0.9 x2 IT plus 4x3 IT plus our error term, which I think in this case I said was just E. And in this example, we have x1 is years of education. X2 is experience in years. And then X3 is whether or not you've had a training program. And so we've got a couple of different questions that focus on interpreting this regression equation. And so what we want to remember when we do questions like this and when we see regression analysis is that the x's, the x's are our independent variables, our explanatory variables, and they are having some marginal effect on y. So we're determining wages, in this case, with education, experience, and training. So the first question asks, what is the marginal effect of one additional year of of experience on wages, all else held constant? So where's experience? It's right here. The coefficient for experience is 0.9. So what that tells us is we multiply years of experience by 0.9, and so each additional year of experience is going to tend to increase wages by 90 cents. So the marginal effect of an additional year of experience on wages is going to be 90 cents, all else held constant. Does that make sense? That's what this coefficient, this estimated beta, is explaining for us. Okay? The next question asks what the estimated wages would be for an individual with 16 years of education, 3 years of experience, and no training program. So for X1, we have 16. For X2, we have 3. And for X3, we have 0. So it's going to be 1.76 plus 1.2 times 16 plus 0.9 times 3 plus 4 times 0, which we can go ahead and add up. So that's going to be 1.76 plus 1.2 times 16 gives us 19.2. 0.9 times 3 gives us 2.7. And then this is just going to be 0 because 4 times 0 is 0. So it's 1.76 plus 19.2 plus 2.7 is going to give us a wage of $23.66. Does that make sense? Hopefully. Hopefully it makes sense. If not, let me know. But the big idea here is that we solve this through to get our answer. Okay? So that is part B. Part C says if X3IT has a value of 1 if the person completes the training program and 0 if they haven't, what kind of variable is X3IT? It's a dummy variable or a binary variable. But basically what we're saying here is it's a variable that's not a marginal change like years of experience, years of education, dollars and wages. It's either on or off. It's a switch. So if you either do the training or you don't do the training. And so you either get this coefficient for doing the training or not. Does that make sense? The next question says, if this sample was taken from employees at a software company, do we expect the results to have external validity? What would you expect the regression to describe the determinants? Would you expect this regression to describe the determinants of wages in an Amazon warehouse? And so we want to remember, first of all, what external validity means. External validity is this idea that we can take what we see in this equation and apply it to other populations, other groups. So if we're using it to define the wages of software engineers, it might make sense. education is going to have a big impact on your wages as a software engineer, and so will experience. On the other hand, if we think about an Amazon warehouse worker, do we think education is going to have a bigger impact on their wages than experience? Maybe, but probably not. It doesn't seem like that's a big education job, and so we don't expect it to require many years of education to work in an Amazon warehouse. And so what that tells us is that this equation might not have external validity for less educationally intensive careers. If it's designed and based on a population where education played a really big role in determining wages, it's not going to do a good job of defining the effect of education on the margin, the marginal effect of education on wages for populations where that's not true. How do we improve that and increase the external validity? Well, we would want a more diverse sample. We'd want a sample that includes warehouse workers and software engineers and grocery store clerks and people who work in administrative assistants and all different kinds of careers where the marginal effect of education and experience is really diverse, because then we would have external validity because we'd be looking at the effects for people in lots of different jobs with lots of different educational expectations. Does that kind of make sense? I hope so. Let me know what you think. Let me know what you'd like more experience with, and I'll see you next time. Bye.